Alright, so I'm going to be talking about the broader impact section of our project. So, our study is very relevant to Portland as a current city and as a future city, and to urban ecology in general, as pollution in its various manifestations has direct impacts on the public health of urban communities and on the ecological health of Portland as an urban hub. So, factories in urban hubs and other anthropogenic sources all directly affect the land, rivers, air, and people in their proximity and even in great distances from their physical locations. Factories and other anthropogenic sources produce and release all kinds of harmful toxins in the lands their facilities are built on, which seep into soil, infiltrate streams, wetlands, and rivers through groundwater and stormwater runoff, and also emit toxins into the atmosphere, which can get trapped in the atmosphere and contribute to heat island effects within cities. So, what inspired us to specifically focus on heavy metal pollution was an incident that actually happened about a year ago in February of 2016. So, in the article, the Oregon Department of Environmental Quality, which is the chief regulatory agency of managing sanitary and toxic waste disposal within Oregon, reported high levels of hazardous metals, arsenic, and cadmium in the air near Bullseye Glass Company in southeast Portland and in North Portland in Ouroboros Glass Company. So, near Bullseye Glass, the arsenic was 159 times the safety goal, and for cadmium, it exceeded it by 49 times. So obviously you can see that those numbers are very, very extreme, and communities within half a mile, which were roughly 10,000 people, of those two companies were advised not to eat any produce from their local house gardens, and they also had to take some of their health precautions due to the incident. So Oregon health officials even offered to pay for residents' testing for urine to see if there were any heavy metals that could be detected. Oregon's two senators called the situation a public health crisis, while the head of the DEQ released a statement saying, "We as an agency are not doing enough to prevent pollution from these types of factories." So this incident that was very recent, where hotspots of toxic pollutants emerged and were identified in Portland, prompted us to want to design an experiment that explored heavy metal pollution mitigation through constructed wetlands. So in our research, we directly focused on what design elements would be the most effective for heavy metal filtration in urban constructed wetlands. So although the airborne emissions from the two glass companies were released into the air, the case itself still shows how stormwater can spread heavy metals and shows the importance of stormwater management. The case also shows that anthropogenic sources within urban areas are directly releasing heavy metals, airborne and through liquid and solid discharges, both of which make landfall and make contact with stormwater runoff. So in relation to public health, arsenic can cause lung, skin, and or bladder cancer, while cadmium can cause lung cancer and or kidney damage. Particulate matter in general can cause premature death, aggravated asthma, irregular heartbeats, and each different toxin has its own health hazards. So for our experiment, we were focusing on arsenic, cadmium, and other heavy metals. So our study contributes to urban ecology and design for all of the ecological and public health reasons that I just talked about, but it also contributes to urban design specifically because we are directly trying to find the most effective ways that constructed wetlands can be built and designed to mitigate water pollution from heavy metals. So the implications of our findings are that they can be used as recommendations for local, city, and state policies and regulations. So for example, certain industrial sites or companies or buildings need to incorporate certain green building designs and features like constructed wetlands to help manage stormwater runoff and to help mitigate heavy metal pollution. So the findings can also be used for any anthropogenic sources already planning to design constructed wetlands so that they can figure out which biosorbents to use and which biosorbents are the most effective at filtering water, which is exactly what our research contended to do. That is it for my section. Thank you.